All right. Again, I'm going to kind of go through some of the basic terminology pretty quickly. Kind of skip over definition of a line and a line segment. An angle, what we're focusing on is the measure basically of the opening. That's what the angle is. We're looking a lot with that. The angle was generated by rotating the terminal side away from the initial side. Okay, so initial means the starting point, and terminal side means the ending point. The more of a rotation that we make, then the larger the angle is going to be. We have a couple of different things with angles. We can have a positive rotation and we can have a negative rotation. So a positive rotation is when we move counterclockwise from the initial side. So if I have the initial side here and I rotate counterclockwise with the terminal side, that gives me a positive rotation. If I move clockwise, then it gives me a negative rotation. Okay? Most common unit for measuring, and what we're going to spend most of our time with, is the degree. We can also break degrees down into parts, and so we'll look at those a little bit later as well. Okay? Now, a complete rotation is 360 degrees, okay? So a full circle, one full rotation is 360 degrees. I can continue rotating past that to get values greater than 360, but every full rotation is going to be a multiple of 360. A couple angle classifications. If the angle is between 0 and 90 degrees, we call it an acute angle. It's a cute little angle. Right angle, it's going to be 90 degrees. Okay, right angle makes it 90 degrees. Obtuse is greater than 90 but less than 180. And then a straight angle is 180 degrees. Now we can rotate past that, but when we do, what you'll notice, if I've got my initial side and then my terminal side, and I rotate past 180 degrees, well, what I'm doing on the other side is I'm forming another angle, and that would be considered an obtuse angle on the concave part. If I go past 270 degrees to something here, I rotate past 270 degrees, well, then on the concave part, I end up with an acute angle. So that's why we only have those 4 classifications, because even as we continue to rotate, we get what's called reference angles, and that's going to also affect how we name it. All right, so starting with some angle relationships, the most basic ones are complementary and supplementary. Okay, the vocab sometimes gets mixed around. So complement, think of a compliment. You give somebody a compliment. You're all right. That's a compliment you can give somebody. A complement is a right angle. 2 angles added together that form a right angle. So if I'm looking at an angle of 40 degrees and I want to find its complement, I have to ask myself, 40 degrees plus what angle adds together to give me 90 degrees? 50 degrees. So the complement would be 50 degrees because the sum of 50 and 40 is 90. If I want the supplement, it's the same idea, but I want to measure to be 180 degrees. So what angle measurement will add to 40 to give me 140? So its supplement is 140 degrees. So complement, some of the angles is 90. Supplement, some of the angles is 140. Now, we can use this idea when we have algebraic expressions as well. If I have a right angle and 2 angles that I don't know the measure of either one, I still know that the sum of them has to be 90 degrees. So let's label this as angle A and this is angle B. I know since these are complements and that they form 90 degrees, they have to add to give me 90 degrees. Now I don't know what angle A is, but I have an expression that represents that angle. I don't know what B is, but I have an expression that represents it. So now what can I do with those expressions to simplify? Say again? Add them up. So 6x plus 3x is 9x. And then I want to solve for x. Divide by 9. So what does x equal? 10. So if x equals 10, what's the measure of angle A? 60. Since A is 6x and x equals 10, the measure of angle A is 60. And the measure of angle B is 30. Okay? We can do the same thing with supplements. So if I have supplements, what does the sum of the angles have to be? 180. The idea is still the same. I can add the like terms, solve for x. So then what's the measure of angle A going to be? That first angle. X is 18. What's the measure of angle A? What about angle B? 108. Okay? So some pretty simple relationships. The trick will just mostly be remembering the difference between supplement and complement, which one's which. Okay? I see those mixed up most often. Complements 90 degrees, supplements 108. Okay? Now, we can break up a degree into smaller parts. So we can write degrees using decimals. Sometimes we'll have decimals, 35.7 degrees. Okay? Or we can break it up into what we call degrees, minutes, seconds. Okay? It's very similar to time on a clock. Okay? So we have the degree. Well, part of a degree is going to be the minutes. 60 minutes equals 1 degree. Okay? There are 60 minutes in 1 degree. And there are 60 seconds in 1 minute. So you can kind of think of degrees as like an hour on a clock. There'll be 60 minutes in that 1 degree. And then 60 seconds for every minute. So there's a couple things we can do. We can perform some calculations, but we have to remember that the 60 seconds per minute, 60 minutes per degree, and it's not based out of 100. If I want to add these two together, okay, 51 degrees and 29 minutes, 32 degrees and 46 minutes, I can add the degrees together. I can add the minutes together. Okay, start with the degrees. What's 51 plus 32? Say again. 83 minutes. Okay. Now, 29 minutes plus 46 minutes. Or 46 minutes plus 29 minutes. 75 minutes, right? Okay. But if I told you it was... No, it's minutes. Seconds is 2 tick marks. No, but I didn't agree. But if I said it's 11 o'clock and 75 minutes, what time is it actually? It's 75 minutes past 11 o'clock. Yeah, so it moves me into a new hour, right? So same thing here. Since I only have 60 minutes in a degree, I can't go above 60 in the minutes portion. So that 60 turns into an extra degree, making it 84, because this is going to be 1 degree and how many minutes? 15 minutes. So that 1 gets added to the 83, and then I'm left with the 15 minutes. So you have to keep that in mind when you're adding degrees, minutes, seconds. Say that again. take the time 11:30. Okay, add 45 minutes to it. What time is it now? It's not 11:75, right? It's 12:15. So once you hit 60 minutes, well, then the hour rolls over, and then you're left with 15 minutes. It's the same thing with degrees, minutes, seconds. Once we hit 60, so I had 75, the 60 rolls over to make the degrees go up, and I've got 15 left over. Okay? Now, same thing with subtraction. But sometimes we have to borrow. So if I have 90 degrees and 0 minutes, and I want to subtract 73 degrees and 12 minutes, okay, if I subtract 0 from 12, I end up with a negative. So I need to borrow from the degrees. So I'm going to take 1 degree away, make it 89. And if I take away 1 degree, how many minutes is that going to be? 60. So I'm borrowing 1 degree to give me 60 minutes. Now I can do the subtraction. So 60 minus 12. 48 minutes. And then instead of 90 minus 73, I'm going to do 89 minus 73. So 16 degrees and 48 minutes. But borrow, because I didn't have enough minutes in my first term to subtract the minutes in the second term. I get 16? There's 60 minutes in 1 degree. So I took away one of the degrees and turned it into minutes. Alright? Conversions, back and forth between decimals and degrees, minutes, seconds. Since it's based on that ratio of 60 seconds in a minute, 60 minutes in a second, it's going to be either a bunch of division and adding or subtraction and multiplication with a 60. Okay? I want to convert this into decimal degrees, and I need to round to the nearest thousand. So I'm going to round at the end. Okay? I'm not going to round before, but I'm going to round at the end. Okay? 74 is my degrees. So 74 is my whole number. Okay? That's going to be the whole number. Which is nice because it's not going to change. It's going to be 74. Point something. So you figure out what that point something is going to be. Alright? The 8 minutes 14 seconds is going to be the decimal. Now, in order to turn that into degrees, I first need to take the seconds and turn it into minutes. I need to turn the seconds into minutes. So, if I have... Actually, let me explain the math behind it. Okay, we're doing unit conversion. Okay, so if you ever get confused on whether you need to multiply or you need to divide, think about your unit conversion. I want to end up with minutes. 1 minute over 60 seconds. Okay, that's my ratio. 1 minute to 60 seconds. I want to end with minutes, so I'm going to put that on the top, and I have seconds on the bottom because that's the one I want to get rid of. I want to convert 14 seconds into minutes. So I'm going to set up my unit conversion with 14 seconds. So then I can cancel out those units, and I'm left with 14 over 60, which just simplifies to 7 over 30. Okay? Which gives me a decimal. It's like 2.3 repeated. Okay? I'm going to leave it as a fraction, but now this is a fraction of a minute. 7/30ths of a minute. Okay? So if I have 7/30ths of a minute and I also have 8 minutes, then total I have 8 and 7/30ths minutes. So I went ahead and I took 8 minutes and 14 seconds and I wrote it all as minutes 8 7/30 minutes. Okay, 8.2 minutes if we wanted to round. Okay, it's around 8.2 minutes. Now what I need to do is take the minutes and turn it into degrees, and that'll give me the final decimal. I'm going to do the same process. What I did here is I took seconds and I divided it by 60. Since I'm still going up, I'm going to do the same thing, but with minutes. I'm going to take my minutes and divide them by 60. Now, since it wants us to round, we can go ahead and do this calculation, and we can round. So, somebody with their calculator, 8 7/30 divided by 60. This one was turning seconds into minutes, and then now this is turning minutes into seconds. Okay? Or minutes into degrees. Yeah. So this took seconds to minutes, and it's taking minutes to degrees.
So how do you change decimal?
Hit math and go down to decimal. Because you're going to have to round to the thousand.
Those are for
0.1.
37.
3. It's thousands place, so you want 3 decimals. Because it wants the thousandth place. So tens, hundreds, thousands. Alright? So that's our decimal part of our degrees, minutes, seconds. So we took the seconds into minutes by dividing by 60. Take that, add it to our minutes, then divide by 60. That gives us the whole decimal value. The whole number stays the same. So if you're going from degrees, minutes, seconds to decimals, divide by 60, add it to minutes, divide by 60, add it to degrees. There you go. Divide the seconds by 60, add it to the minutes, divide the minutes by 60, add it to the degrees. Divide, add, add. Now if I'm going from decimal to degrees, minutes, seconds, it's going to be the opposite. Multiply, subtract, multiply, subtract. I want to go from decimal to degrees, minutes, seconds. Now again, the whole number is the whole number. That's still going to be the degree. 34 point whatever is still 34 degrees with some minutes and seconds. So I'm going to have 34 degrees. I just need to now figure out the minutes and the seconds, which is where the decimal comes in. 0.817 degrees. Now I want to turn it into minutes. Multiply by 60 because we're going the opposite direction. So I'm going to multiply by 60. So what is that? Multiply by 60. 49.02. Okay. So this is now minutes. So I have 49 minutes, and then I have some decimal of a minute. So again, the 49, that's the minute. So I'm going to focus again on the decimal to get the seconds. 0.2 minutes times 60 gives me how many seconds? 1.2. So going DMS to decimal, you're going to divide by 60, add, divide by 60, add. Going from decimal to DMS, multiply by 60, multiply by 60. Focusing just on the decimals. Keep the whole numbers, multiply your decimals by 60, and then you'll be able to fill in your degrees, your minutes, and your seconds.
Do you have any tissues?
Yeah, the box right.
Thank you.
Alright, last thing we're going to talk about is standard position and what we call coterminal angles. Okay, so we talked about the initial side and the terminal side. When we have an angle in standard position, the initial side is on the positive x-axis. And we rotate around in the coordinate grid. I can do a positive rotation, and I can go from quadrant 1 to 2 to 3 to 4, and I can go around and around and around. I can also do a negative rotation the other direction if I want. The location of the terminal side from quadrant to quadrant is going to mean more to us later as we apply this with some different trig functions. If you have a terminal side that's not in a quadrant, meaning it's on your axis at 90 degrees, 180 degrees, 270 degrees, since it's not in a quadrant, I can't say that it's in quadrant 1 or 2. It's on the x-axis or it's on the y-axis. We call those quadrantal. Okay? Just a different name. If it says it's on the axis, it can't be in a quadrant, so they're quadrantal. So now talking about coterminal angles. If I take an angle in standard position and I rotate 60 degrees, I end up with a terminal side in quadrant 1. If I take another angle and I rotate it 360 degrees plus another 60 for a total of 420, I end up in the exact same place. So for all intents and purposes, they're the same angle. They have a different rotation, but they essentially are the same angle. They have the same measure. Okay? We call these coterminal. They end up at the same place. I could do a negative rotation and do the same thing. If I wanted to, I could take another angle and I could do a negative rotation by negative 300 degrees and still end up at the same place. They're coterminal because they end at the same place. All right, and we could do multiple rotations. I can do 110 degrees, and then I can do 2 full rotations plus another 110 degrees to still end up at the same place. Okay? So oftentimes we're given angles that are greater than 360 or maybe less than 100, but we need to know what values are associated with it. So we need to make sure that we can find the coterminal angle so that then we can actually use it. So I want to take the angle of 908 degrees and pay really close attention. I want to find the angle of least possible positive measure. That means the smallest angle that's still positive. Finding coterminal angles is just a matter of adding or subtracting 360 degrees over and over and over until you get what you want. So if I want the smallest possible positive measure, it's going to be an angle that's between 0 and 360. That's just the one rotation. Okay? So we take 908. And if I want to get it to between 0 and 360, am I going to add or subtract from 908? Subtract. Go ahead and subtract 360. What do I get? Is that between 0 and 360? Then I got to do it again. Is that between 0 and 360? Yeah, so then I'm good. 188 puts me somewhere in quadrant 3. How do I know that? Because I've been doing it a long time. A straight angle is what measure? 180 degrees. Each of these are 90. 90 degrees, 180 degrees, 270, 360. So I've got my angle in quadrant 3. We did 2 full rotations, or we took away 2 full rotations before I got to 188. So that means 908 was once around, twice around, and then back there. But they ended at the same place. Because I took away 2 rotations. That's how I know it's twice around, plus 180. Because I went 360 degrees, and then I went 360 degrees, and then I went 188 degrees. So I went once around, twice around, and then ended at our terminal side. All right. Now there's a little bit of a shortcut, especially when you have these bigger numbers. Okay. 908 divided by 360. Just give me the whole number. So 2 point something, right? Okay.
Same problem.
Yeah, I'm telling you it's a shortcut. Instead of subtracting over and over and over. If I divide 908 by 360, I get 2 point something. So that means that I'm going to have 2 rotations and then something left over in that angle. So instead of subtracting 360 over and over and over and over and over, if I figure out how many rotations I need to get rid of, I can just say, oh, well, I need to do 908 minus 2 full rotations to get my angle. It's going to be the same thing. So if you want to subtract 360 over and over and over and over and over, you can. But if you can figure out how many rotations you're going to have, then you just have to do one subtraction. So I know I'm going to have more than 2 full rotations, so I want to take away the 2 rotations. Now, if I have negative 75 degrees, that means I rotated clockwise from my initial side. I started on the x-axis, and I rotated clockwise negative 75 degrees, somewhere in quadrant 4. Again, I want the least possible positive measure. So if I have negative 75 degrees and I want the positive angle, what do I need to do with 360? I need to add it. Because I need to get from a negative angle to a positive one. So negative 75 degrees plus 360 degrees. Okay, so then I get 285 degrees. It's between 0 and 360, so I don't have to do it again.
So is it always has to be?
You have to pay attention to what it says. So it says find the least possible positive measure. Least possible means the smallest you can get that's still positive. And so that means since our full rotation is 360, it's going to be 360. It may ask for 2 positive and 2 negative. It may say just give me a negative coterminal angle. Then as long as it's negative and coterminal, it doesn't matter. You could subtract 360 as many times as you want. If it says any positive, then you can give any positive. So you got to make sure you pay attention to directions. Most of the time, this is what we want because these are the angles we're going to be using for various things. Okay? Now, I have negative 800. Okay? That's a lot of rotations in the negative direction. So first, I want to figure out how many rotations that is. 2 point something, right? So divided by 360 gives me 2 point something, right? So that's going to be more than 2 rotations in the negative direction.
Wait, why'd you divide again?
Because I want to figure out how many rotations that is. Yeah, you just add over and over and over and over. But I want to figure out how many rotations. Okay, there's a lot of you talking at the same time, and some of you aren't even talking about the right thing. Finding coterminal angles, we add or subtract 360 to get to wherever we want, but we have to do it over and over and over. Negative 800 is a big number. That's multiple rotations around and around and around. So option 1 is you can do negative 180 plus 360, and then again, until you get to where you need. If you divide by a rotation and figure out how many rotations it is, it can get you there a lot faster. Okay? So negative 800, okay, plus, right, so we have more than 2 rotations, right? Now 2 rotations, because I'm negative, is still going to put me in the negative. Here's 1 rotation, 2 rotations. I have more than 2 rotations. So if I want something positive, I have to go once, twice, 3 times around in order to get it to positive. So instead of multiplying by 2, I'm going to do 3 times 360. Okay? When I'm starting with a positive, here, okay, I can subtract the same number of rotations. I'm going to still end up positive. But because I started negative, I have to do an extra rotation to get into the positive. And if you only did 2, it's not that big a deal. Just notice you're still negative. Add another 360. Okay? But what is 3 times 360? 1,080. And then once I add those together, that's going to give me a positive number. If you only did 2, you should see that you'd have 720, which isn't going to be enough to get you to a positive. So I can add these, and then now what do I get? Okay. If you just added 360 3 times, you'll get the same answer. All right, and that's our introduction to our angles. Yeah.
Every time you get a negative, let's say I get 4 points on it. Would it turn into 5?
I would do 5. Yeah, I would do your angle plus 5 times 360, and that'll give you the positive cosine.